Let it not be said that I was responsible for chasing Eric Williams. No, thank you, Eric, for a wonderful presentation. And I think it's nothing beats on-the-ground experience to know exactly what to do if situations like these come about again. Okay, we move on to our second presentation, which is from the TNTech, from the Trinidad and Tobago Electricity Commission. Fresh from the West Moorings experience yesterday, so I think it's quite topical. The presentation is being made by engineer Ravi Shukla, who holds a Bachelor of Science degree and Master's of Science degree in Electrical Engineering and an EMBA from UE, St. Augustine. He joined TNTech in 1984 and has now risen to the position of Assistant General Manager, Transmission Division, with responsible for the development, operation, and maintenance of the transmission and sub-transmission network in Trinidad and Tobago. So without further ado, I'd like to introduce Mr. Shukla, Engineer Shukla, to present his presentation, TNTech Transmission System Design Management, Planning, Design, Construction, and Maintenance. Engineer Shukla.
Thank you, Dr. Fazil Mudin, members of the head table, fellow presenters, fellow delegates, pleasant afternoon to you. I know you are wooed by the arms of Morpheus, but we'll try to energize you somehow. Okay, so today this is the presentation outline. Overview, we'll have a slide on the TNTech context, overview of the transmission system and potential threats, system planning, design, procurement, construction, and maintenance as all play those activities in putting together a robust transmission system. Transmission line failure modes, very basic failure modes. Overview of the transmission hurricane plan, TNTech's transmission hurricane plan and strategies. Critical role of suppliers and contractors, national planning and coordination, and imperatives for TNTech. I'd like to thank Engineer Williams for providing some wonderful pictures, which I'm happy to say we don't have. Seen that we don't have many storms in Trinidad. So but if you could remember some of his photos, you would see the relevance here. In addition, a lot of the points he made previously would apply to us here. A lot of things are basic common sense. TNTech established by Ordinance 1945 and by Act in 1970. We have about 440,000 customers. We all metered through the automatic metering infrastructure, 2,700 employees, and approximate sales of 8,500 gigawatt hours. Current peak demand, 1,332 megawatts, and our generation is private, so we have IPPs, 3 generating stations. We have the Power Gen, we have Trinity, and we have TGU. We have our own generation in Tobago, Cove generation. We have one of the lowest rates in the region, 6 US cents per kilowatt hour. And of course, we are regulated by the Regulated Industries Commission. Just an overview of the transmission. Generation, transmission, and distribution all make up the components of the power system. The transmission system plays the role of linking all generation stations to distribution stations and each other. In the case of TNTech, the transmission consists mainly of steel lattice structures and poles, 17 and 21 meter poles. Our voltages go from 33,000 to 220,000 volts. And we have underground cables, mainly in the Port of Spain area, from 33 to soon to be 132 kV. There is an undersea cable linking Trinidad and Tobago, and that operates at 33 kilovolts. We have approximately 15 transmission stations that are critical to the grid, and a few of them are super critical in the sense that if they go down, most of the country will go black. Potential threats. We're looking at this presentation is taking the system from the natural disaster standpoint. Overhead lines, hurricanes, as we heard before, previous speaker spoke to that. Lightning as well, and I was happy to hear this morning the chief the Caribbean Meteorological Office. They're talking about predicting lightning or developing lightning models. That'll come in handy for some of the management of lightning, landslides, and flooding. Underground systems susceptible to flooding, landslides, and earthquakes. Earthquakes affect the cable systems and the distribution systems more than the transmission because of concentrated loads. Of course, the substations are affected by earthquakes. Substations, earthquake, landslides, flooding, and lightning. These are the kinds of these potential threats we have. Of course, we have the human impact as well, pilferage of structure members. Trinidad, we have people stealing the members for fence post, sabotage. Recently, some of our towers were cut. Not recently, a couple of years ago. Has nothing to do with oil spill. Tethering of animals, and of course the chaos that ensues after natural disaster, theft and all of that. If we look at the activities to establish any system infrastructure, there's the planning aspect. What we do, we have single planning contingency, that is, if one component is out, the system could survive, carry the load. We have double contingency as well for critical interfaces. So where we have more than 5 lines or so terminated in a particular area, we design for double contingencies. A lot of our circuits, the major circuits, are double circuits. What double circuit means? You've got 2 circuits on one structure. That has a weakness in the sense that if you lose the structure, you lose 2 circuits. So it's like a double contingency in one for one event. I'll talk about that a little later. Generation, sizing, and location. What happened in Trinidad is our generating sites are located in such a way that if we have islanding, and what is islanding? Islanding is if you have major transmission disruption, the system breaks up into so-called islands where Port of Spain could be disconnected from Point Lisas and San Fernando and so on. And the generation in the locality would be able to carry most of the load. That is not a deliberate design, but it has come out of the planning for generation close to load centers. So the way we have it right now, Tobago can run on its own with the new plant there. In fact, the plant is about nearly 1.5 to 1 3/4 times the load in Tobago. South is more than adequate with the new generation. It can support itself and feed the rest of the country. Point Lisas, close to this area, could take care of the central. The challenge is in Port of Spain. That plant was at 300 megawatts and could have sustained Port of Spain and the near environs, but the plant is the oldest plant and it's soon to be decommissioned, so it's really not reliable. So if we do have such an event of islanding, hardly likely that station will be able to sustain Port of Spain. Design. Routes. Line routes, this is very important in terms of reliability and even security. If we're looking at the single contingency, obviously it would be better to route one line or one circuit, and the second circuit will be far apart. The constraint really being the land, available land. And in Trinidad, we have quite a constraint in the available land for routing lines and even substation sites. What I've said in the first point is our major transmission is on the western side, and that has happened of the country. That has happened because of the industrial development. It stretches from La Brea south up to Port of Spain, and it's almost on the west coast. So the major transmission is on the western side, which is good in a sense that if we looked at the hurricane belt and the slide that Engineer Gibbs showed us, the Tobago is more susceptible to higher wind speeds and the northeast Trinidad, but the south and the western is less susceptible. Downside is that some of the infrastructure is very close, and in fact the 132 kV intended route is on the waterfront. So if we have any kind of storm surge and so on in the Gulf, it could affect some of the infrastructure. We discussed the co-located, because of land issues, we have to co-locate lines, and we have the double circuit. And of course we have challenging terrain like heavily forested or swamp areas. Engineer Williams spoke about that and the effect of vegetation management and so on. what I think we lack in the country is coordination for planned utility corridors and highways. These could do well. Joint corridors would make better use of the land, and we can discuss disaster planning with the joint and coordinated corridors approach from the planning stage. Substation design, we're looking at close to load centers. Generally, we locate substations close to load centers. Now, I'm not going to, we had a lot of discussion earlier before the break on flooding, so there's really more detail on flood design and so on. But generally speaking, we have the turtleback design and, of course, the drainage with all the hydrology and all of that that goes with it. Problem in Trinidad, land issues, and many of our substations are located close to rivers. In fact, we had 2 years ago, or 2.5 years ago, we had one of our major transmission substations was flooded out. And the way it's located, it's almost like in the center of a bowl. It's the Harmony Hall station close to Ready Mix at Gasperlo. The roadway is higher than the substation. The river is close to the substation, and the water will naturally collect there. And someone mentioned before, I think it was Dr. Khan was talking about the pollution in the rivers in terms of dumping garbage and so on, and that created a lot to the backup. But the Guaracara River flooded, and we suffered some issues there. Design, and we spoke to. Other speakers spoke about this before, wind and earthquake codes. You'd see they have mentioned engineer Tony Gibbs, Gentech in 1998, and I think in 2008 we sought the advice of engineer Gibbs, and he gave us a wind criteria that's suitable to the TNTEC system. So we use that, and generally for the transmission we use the 100-year wind, 3-second gust. Based on the values, the basic wind speeds that we got from Dr. Gibbs in his report. Currently, the earthquake code is there. We have the IBC category for occupancy, but I think based on the discussion today, we need to revisit some of these things in line, of the local codes. At one point, we spoke with Professor Chin about the use of the cubic. He was invited into TNTEC, I think around the same 1998 or so, to see the application of the cubic, if we could use it in our design. So that discussion has to go on. I think Engineer Gibbs spoke about that this morning. We need to get the relevant codes and applications to the region. In terms of the line itself, the structures, they are designed for various mechanical conditions, including broken wires. So everyday winds, high-speed winds, broken conditions, and the appropriate safety factors. So one designs with certain failures that will occur, naturally occur, and to design the structures to withstand these problems. We will talk about strength coordination a little later in terms of how the whole transmission line and the different components, how they interact with one another. Some of the recent design improvements we've made is we use strain structures with double insulators and higher factor safeties at highway crossing. So that way you can imagine these things crossing highways. We have the hurricane event or any natural disaster. We want to have stronger structures at those points. We also look at strain structures for failure containment. Now, this isn't so much a problem in Trinidad because hardly we have a straight line between points. We always have lots of turns and so on because of features and land issues. So inherently, we have lots of strain structures per kilometer in our line. But places like the States and so on, where you have hundreds of miles of line, and a good section could be a few tens of miles well, the domino effect, if you lose a structure, you'll find that many of the suspension structures fail. So that's something, failure containment using strain structures. Now, proper foundation design, the speaker before mentioned the foundation designs and GAIN designs. Obviously, this is standard civil engineering practice and so on. But what we should, especially for GAIN designs, you see, we have standard guy-in arrangements, but and it's as though one guy-in arrangement would satisfy will be used in all soil type conditions. We also have to consider the effect if you have wet storms or wet conditions, would the guys be effective? So that is something that we look at, especially at the transmission poles. Okay, we went back there, so we go forward. Yeah, that was revision. In terms of lightning, these are standard. It's nothing, no sort of breaking edge technology here, but it's something to do. We look at the highest chironic level at Piaco, but now with the weather systems mapping lightning a little better, I suppose we'll get better information. Of course, the standard practice of surge arresters at the interface, lightning will come with the storms and they could knock out system, damage equipment, etc. So we need to design for lightning and, of course, appropriate basic insulation levels and so on. It's not a lecture on insulation coordination, but just to mention some of the things we need to do. It's important to have low footing resistance so you prevent back flashovers, which means that you can have an outage for lightning that doesn't strike the conductor directly. Sufficient electrical clearances, line corridor widths, and building setbacks. Now, depends on the policy of the utility, and our policy is to keep the lights on during the hurricane. You need to cater for blowout. Now, this is not electrical blowout, this is the mechanical movement, or physical movement of the conductor with a high wind. So you need to set sufficient clearance from buildings and other structures or other lines so that you don't cause electrical shock or damage or trips. This means, of course, it could entail having wider corridors and land issues. So that is something to bear in mind. In addition, Engineer Williams spoke about vegetation management, and we need to have wider right-of-ways for the transmission lines in terms of the trees. Trees fall on our lines and so on, and we need to clear a wider corridor to prevent that. In terms of procurement, so we dealt with the planning activity, dealt with the design activity. Let's look at procurement. Of course, the equipment must be specified with the proper design, wind speeds, earthquake criterion, environmental and BIL parameters. Appropriate factors of safety for the different elements of the line hardware. Now, in our case, I suppose most utilities, underground cables, we specify an impervious layer, so we expect flooding and so on. So if it's impervious, it will improve the performance. Of course, the appropriate materials for the environment, if it's coastal, if it is highly corrosive, etc., then this is key, and we have a major challenge in Trinidad to procure quality goods and services. We have to use, by and large, public procurement. As I said in the first slide, we are public utility, not private, so we have to do public procurement, and we do get quality issues. And this is very critical, and could never overstate the importance of having quality materials. Construction, of course, must have the competent workforce. And a contractor, again, we talked about goods and services, so you may have good materials, good designs, everything, and if your construction is poor, it doesn't work. So proper construction techniques, tight quality control during construction, material specification, and so on. I think Engineer Gibbs talked about a project in Labre with the Atlantic LNG, 0.14, and the design reviews, but I think the same applied for the equipment and even the construction. One thing though, not everything in paper, you design on paper, could happen out in the field. So if you have to make any changes, it must satisfy the design and performance requirements. And those have to be vetted. So you just don't make changes. Our contractors have the temptation to change the design out there, thinking that they know how it will work, but that has to be verified and so on. And of course, the codes we use there for construction. Maintenance, critical, and some speaker before mentioned it, and we are weak in this area, means if it's drains or generally speaking. Periodic inspections on infrastructure to identify the condition. Planned maintenance based on that information. Aggressive vegetation management. Of course, our problem is land issue versus expanded right away. There's always a trade-off there. Then, in the case of maintenance, whenever it's performed, many times we have, quick fixes, and it compromises the original design and performance specifications of the line. So we have to ensure that whatever maintenance we do, it must restore the original or exceed. Recently, a couple of years now, they're talking about utility hardening. What utility hardening really is to improve the infrastructure to meet the worsening weather systems, and as was predicted, we'll have worse weather conditions in the future from the point of view of storms and so on. So if maintenance is done or refurbishment, we could look at hardening, looking at higher wind codes or higher earthquake design, what's appropriate. Of course, everything we got to balance with cost. Let's look at the transmission line failure modes. Components, basically the foundation, the structure, the conductors, and the insulator line. A term I learned from engineer Gibbs is that transmission structure could be considered as an aeroelastic structure. So think of the whole thing as one. Two types of structures generally. We have the strain, tension. These are different names for the same thing. Strain, tension, angular dead end, which basically holds the tension of the line. Then we have the support structures, which will be the tangent, the suspension structures. The problem is, if you lose the strain, you have more damage. But if you lose a suspension, chances the conductor will hold up the structure. You will see that happening in many cases. Failure modes. Of course, if we have soil erosion, landslides, earthquakes, human impact, these could affect the foundation, of course, weakening the capability to withstand any event. Structure failure, the broken conductor, broken made burst wire, because the wires, the whole thing works as it says, one structure, and they work in tandem. Failed insulator strings, that's another component. Missing or cut members, I mentioned about the pilferage or, the sabotage. Loose guy wires, and these things happen especially during the wet conditions where the guy blocks might pull out, and we have a problem there. Or because of tethering, excessive period of tethering of animals. And of course, excessive corrosion. So your components could be corroded and would not withstand the events like high winds, fallen trees, etc. Conductor failure due to high winds, corrosion, sabotage, wind-induced, and inappropriate line tension. That is very critical. The line tension has to be, that's one of the most important things you need to monitor during construction. And people tend to just do stringing by sight, but we need to reference it to the proper design tensions. Insulator, hardware, string failure due to corrosion, that we've had those problems. So these are all things we need to look at. Now let's look at the strength coordination versus cost. Now I haven't put cost there, but just to give you an idea. Those are the components: foundation, structure, steel. And we're just referring to steel here, conductor and insulator. Now if you notice, in choosing your factor of safety, well, one option is we have the lower ones at the foundation and the structure, and higher ones at the conductor and insulator. Well, this is a little more cost effective because, of course, you have less steel in the insulator line hardware and conductor, and more in the structure, and of course, the foundation. One could say, well, look, let me have a very strong structure, say go 2.5 or something. Okay, I'll take a 1 on the conductor and probably go low on the line, the insulator. Problem is, if you during a hurricane event and you lose, let's say your conductor string breaks or your insulator, you subject the foundation and the structure to very severe loads. Those could be prevented if you put more strength in the conductor and the insulators and so on, and let the line withstand the hurricane force winds so that you don't have that problem. So this is an approach. Some utilities would take the foundation a little lower than 1.5. They allow the structure to lean, and then so that if the foundation is at a reduced factor of safety, it means the structure, if it leans, wouldn't have to withstand that full force. And what they do is, but their policy is to de-energize the line. before the event, So it allows it to lean, then they come straighten back and energize. TNTech, of course, we keep it going as long as we could. Now, let's look at the hurricane plan and some of the strategies. Now, some have been well dealt by the previous speaker, so I'll run through that quickly. But what we do is here, our main feeder of fuel is natural gas. Okay, so we depend on the offshore platform. So depending on the severity, after the warning is announced, platforms may either shut down or go on autopilot. We continue our operation during the storm, and the power stations obviously continue. I mean, we can't continue without the power station. The backup control center, TNTech has established a backup control center in Central. We have the main one in Mount Hope. So those go into parallel operations. Now, how do we get it? If we shut down gas platforms, how do we get gas to supply? Well, what happens is in the transmission line, there's a pack, and that line pack is what we use to run the system. In Tobago, we have the facility to switch now back from gas to diesel. So we could go to diesel in Tobago, keep that running, and use the line pack to operate the system. The only thing is we only have about 4 hours of operation because, of course, we'll reduce the loads, the electrical load. We only have priority loads given. Of course, TNTech is given the first priority in natural gas, and we have about 4 hours based on the current system. So if the storm lasts longer than that, but I don't think so, Engineer Gibbs could see if 4 hours is good enough. Okay, the overview of the system, quite similar to what my colleagues said before. Crews, tools, equipment, etc., deployed to various operating centers in preparation for the hurricane. I saw some of this. I was going up to Orlando in, I think it was 2008, and there was this hurricane, tropical storm Faye, and it was following me. I don't know why. And then when I'm driving on the turnpike going up to Orlando, I'm seeing these trucks going down from Progress Energy and Florida Power Line. Say, oh God, what a time I chose to come to this place for holiday. But anyway, they were preparing for the storm. They learned a lot from Gilbert because we visited Progress Energy in 2006, and they had lots of things to tell us about their Gilbert experience. But they were going down and setting up in Miami and Fort Lauderdale and so on to prepare for the Faye. Another thing to mention, and I know Speaker mentioned it before about the underground system. Whilst it is better from the wind standpoint, the wind impact, the flooding though could pose a problem to underground systems. And what I observed there, Broward County and some of the other counties, they couldn't restore supply because of the flood. Faye was quite a wet storm, and it was lazy, so it was dumping a lot of rainfall, and a lot of these systems were underground. Submerged with the floods there, and the crews could not restore power till it was safe. So that is a drawback. The other drawback with underground systems, apart from for transmission to the 66 kV and above, is very expensive. But the other drawback is if you have a failure, it takes much longer to restore than an overhead line system. So it's something we need to take into account in deciding. Of course, the fueling of vehicles, office equipment, and so on, secure backup storage. We mentioned, colleague mentioned about GIS data, but also your business data. You want to be able to restore business as soon as possible. And we set up contracts and so on with external suppliers and pre-qualified suppliers to have stocks and supplies in readiness for use after the event for the restoration effort. This here is just an overview of the transmission plan. We have the command center, which will involve all divisional heads and the general manager. They will liaise with all the external agencies for the national coordination event, okay? And of course, the external agencies and so on. So that was spoken to before. We spoke about this. I wouldn't go into detail here, but the key thing is quality materials and quality construction. That is key, apart from your quality design and procurement. National planning and coordination. This is important, especially for shared corridors. Unfortunately, in Trinidad, we develop our corridors. Each utility will go on its own, and we don't have planned corridors. We also don't look at the effects of failure of one utility and another. So some utility might fail during some event, and that could affect another utility. So these are some of the things we need to do. Coordination, everybody spoke about that, the coordination with key institutions. And of course, the communication, our speaker before mentioned communication. What in Progress Energy, they mentioned satellite phones might be necessary when other phones are down, and I know we have one satellite phone from the OPDM. I think I'm suggesting that we should have national drills. I mean, in Trinidad, we don't get tested too much as the other countries, so we should have some national drills and go through some of these exercises to see how prepared we are for natural disasters. First, in TNTech imperatives, we have a lot of aged infrastructure, so they're vulnerable. Refurbishment and replacement, hardening of that infrastructure is critical, but capital intensive. Susceptible critical locations to be relocated or redesigned for those problems. The standby generators, and the speaker before mentioned that, the government has given, and previous governments have given us monies for setting up standby, I think it's 1 megawatt plants all over, so that at critical locations, so they could run on their own after the event. Formal arrangement with suppliers. A key thing here is the foreign contractors and other regional utilities. Just as my friend mentioned, Grenada depended on Jamaica and Trinidad, so too we would depend on them for things. But for the other things that the Latin American contractors and suppliers will depend on to help us there. And of course, we need to participate in our national planning and coordination. Well, I'd like to thank you because the questions will come at the end. So thank you very much.